going to give you a similar problem, and let's try to solve it as well. Okay, so the problem is like this. I'm given a cone. Okay, I'm given a cone, and this cone has a center to the edge of the cone is 8 centimeters, while the height of the cone is around 20 centimeters. Okay, we are now asked to find find the radius. The dimensions, better use dimensions. Okay, find the dimensions of the cylinder with the highest volume that can be cut out of the cone. Okay, can you understand what the problem is asking you to do? Okay, there are many ways, or there are many sizes of cone that can be removed here. Okay, if you are going to draw a small it on top and then draw another circle, then that's a cylinder, right? Correct? Yes or no?
Yes, sure.
Yes, the size can vary as well. If you do not want that small, you can make it a little bit bigger. Okay? And if you do that, you are now going to end up with a shorter cylinder, but then it has a higher volume. Okay. Do you understand the difference between the two? One cone is like that. One cone is like this. That's small. Okay. Size is different. Okay. And we are trying to find the highest volume. That's our goal, to get the highest volume of the cylinder out of this cone. Okay. So how do we do that? Okay. To do that, you need now to at least find the parts that a formula that you can use to describe what we are looking for. So in our case, we are trying to look for the highest volume of the cylinder. Okay. So what formula can we use? Anyone? There is power outage here in school, and I think our connection is affected. Can you hear me clearly? Yes or no?
Yes, sure. But sometimes it kind of slows down, kind of lags.
Okay. Okay. So anyway, since we are looking for volume formula, what's the volume of this? this thing that we have here. What's the volume of it?
The cone or the cone or the cylinder, teacher? The volume
Again,
of the
sorry.
cone. The volume of the
The
cone or the
highest
volume
of
of
the
the cylinder.
cylinder, because we're
Oh,
looking
okay.
for the on the cylinder, right? So
P r squared h.
maybe 2 pi r squared h, sorry.
Yeah, pi r squared.
So that's pi r squared times h. Okay. However, this is we do not know any of this, right? We don't know what is the radius. Basically, we do not know what r is. We don't know that. We don't know h as well, correct? But we cannot actually work on this because again there are three unknowns. There are too many unknowns there. So we need to at least have two unknowns, and then one of these values over here must be expressed in the form of another. Okay, so what can we do in order for us to at least express height in terms of the radius?
For the volume of the cone first.
Okay, so is the volume of the cone needed in this problem?
I think it should
What
be
will you
teacher
do
because
with that volume of the cone?
to wait.
So volume of the cone, BC, is equal to, it's 1/3 of this volume. So pi r squared h over 3. So volume of the cone is pi times radius, we got 8. 8 squared times the height, which is now 20 over 3. This is the volume of the cone.
We have what? 1,340?
Hmm?
1,340.4.
1,340.4.
Yeah, 0.41.
This is centimeter cubic. Okay, so what's the next step? By using this, okay, the volume of the cylinder, Cy, we cannot get the information on how to convert the height to in terms of a radius. That's a while ago. Yes, we were able to get the volume of the cone, but basically we cannot use this to change any of these values in relating, which is related now to the cylinder. Okay. However, if you look at this one side view, okay, just plain side view, the cone is going to actually, the cone is form a triangle, right? And at this point of view, our cylinder forms a rectangle. Okay, let's make it shorter so that you will not be mistaking it as a square. Okay, they are all connected there at the midpoint over here, and this 8 centimeters that you see there is here, from here to there. The radius that we are looking for, that is r, is from here to here. That is r. Okay, this distance from the tip going down to the center is the same distance as this, correct? which is
20 cm.
You learned this is a cone. So if this is a cone, this and this is this. What we have here is an isosceles triangle, because that's a cone, right? So isosceles triangle. If you cut it in the middle like this is going to form 90 degrees. Since this is a cylinder, inside of the cone, this is small triangle here on top. Also, a right triangle. And it is similar to this half of the triangle over here. This is also R. Okay, what information can we get here? We are trying to find the H of the cylinder. Is there a way to solve for H?
Can use proportion.
Yes, you can use proportion. Very good. So a small triangle compared to the big triangle. So you can actually solve for this part of, okay, we can solve for this part of the small triangle, this aja. Okay, you understand? So making a proportion over here, we will get what? Big triangle, 8 is to 20, okay? So 8 is to 20 is equal to, I'm using this, yeah? Is equal to what part of the small triangle? That will be
8
R.
minus 1.
R is to
R is to X.
X. Yeah. And then that is now going to be equal to 8x. 8x is equal to 20R. So R is what?
2.5x.
R is
Wait, no, sorry. R is, yeah, 2.5x.
8 over
0.4x.
R is equal to 8 over 20x.
0.4, teacher.
8 per 20, 0.4x. Okay, that is now in terms of a radius. Mm, wait. Okay, that is, wait. It's better to solve for x because we are looking for h over here, right? We do not need the x1 over there. We need h. So it's better to express x in the form of h. Okay?
So
So
X equals to
instead
2.5,
of,
teacher.
okay, instead of that one, so x is equal to 2.5 r, correct?
Yes.
Yes.
But what if What is x in terms of h? H is equal to h is equal
20
to
minus x.
20 minus x.
20 minus x. Substitute it here. So h is equal to 20 minus 2.5 r. Okay, so our h now, our h is in terms of r. Okay, and we can now put this here in our volume formula. Okay, so I'm just going to combine it together with this. So volume, using that. So volume is equal to pi times the radius squared times h in this one times 20 minus 2.5 r. Okay, can you still follow?
Yes.
Yes.
Okay, expand. That will now give us volume squared minus pi r cubed. Okay, so this is now our working formula of the volume of the cylinder in terms of the radius. Okay, so this is what we are going to. What's our goal? What is the highest volume? So highest volume means we need to, what do we need to do
get the maximum.
with the volume? Maxima. Okay, we need to locate or solve for a maximum value of the radius. Okay, maximum of the value of radius will now be v prime. Okay, v prime of this one is what?
40 pi r minus 7.5 pi r squared.
40 pi r. 40 pi r minus
Minus 7.5
pi r minus 7.5 pi r squared. Correct? And this one, we need to evaluate this one when the first derivative is equal to 0. So you will have two values of pi based on this. What are these values? Give me R1 and R2. I can think of one. Find R. To make it 0, then I see R over here, I see R over there. So if this is 0 minus 0, so one value is 0. What's the other value? You can
5.3.
do factorization. 5 point? 5
5.3.
point?
Negative 5.3.
5.6. Negative? Really?
Positive.
Oh, yeah, positive.
Positive. 5.3. Okay. And this is radius. Okay. This is radius. Can we have a radius of 0 if you're trying to maximize the
No.
value? No. So this is now rejected. Okay. Rejected. So what we are going to work on is this. Now, if this radius a maximum one or come out as a minimum, then that is not what we are trying to look for. Okay, so we need to check second derivative. So v prime prime based on this, what will you get?
45 minus
40
15
pi
minus 15 phi r.
minus 15 pi r. Okay, and this time we need to evaluate this one. We need to evaluate this one at what? At r equal to 5.3. And what is our value over here? B prime prime is, this is just checking. You can check it mentally. It's a positive value. You put a positive value over here.
It's a negative value, teacher.
It is now going to be lesser
zero.
than 0. So, what is second derivative test lesser than 0? So that means what?
Maxima.
Maximum, minimum.
Maximum.
Maximum. Okay, maxima at r equal to 5. Okay, so that's it. We have proven that it's a maximum. So our answer is radius. The radius of the cylinder with the maximum value or maximum volume is 5.3 centimeters over there. The radius, okay, the radius of the cylinder with the highest volume that can be cut off from this cone is 5.3 centimeters. If you are wondering what is the height of that cylinder, you just substitute that 5.3 here, and you will now be able to get the height. Okay? What's the height anyway? 5.3 at the radius times
6.7.
2.5. That will be 7 point.
6.75.
75. Okay. 675 or 665?
I found 6.75.
You got 6.75. I'll check. 5.3 plus I got 6.65 times 2.5. Oh, correct. Okay, 6.75. There. Okay, so that's it. Just make sure to know when to get your formula. Okay, see, we did not use this, but that happens. Okay, that happens. Sometimes because we are in a hurry or we want to feel that we are doing something, our mind just makes use of this given information immediately, and we ended up doing this. Okay, our answer is correct. However, if we look at in our solution over here, we did not use it in any way. Okay, so the drawback here is we wasted a few minutes instead of spending it thinking for what is the main how to say, instead of using the time to analyze at this analysis, okay, we wasted a few minutes or a few seconds. Okay, it's not a big deal, but if you are in a test, it might affect it might influence how you are going to finish or answer the test. Okay, so that is it. Expect questions like this during the test. Okay.
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 Okay,
so
teacher.
that is it. If you want to have more practice exercises on each exercise from your textbook, page 65 and page 66. Okay, so that's it. You may now move to your next class. Goodbye, everyone.